Okay, so I think I'm live, right? I just want someone to just confirm me if you guys can hear me or not. Okay, properly. So what I'll quickly do is I'll just quickly uh, put the link on Discord and then I'll start with the video. Okay. And someone just tell me if you guys can properly hear me or not. Okay. If I'm properly audible or not. I'll take it as a compliment. Put it on Discord quickly, and then start with the video. I'll just check with the volume. Is it okay? Volume. It is perfect. Perfect. I know. Okay, I've posted on Discord. So let's start with the video, okay? I think it will better like if I could have done it like this, okay? Because I'm putting it on my lap. Proper users of laptop. Just a minute. I'll just put the other device over here and I'll start with it. I have to follow Minty Porcupine. Let's check the first question, okay? The first question is check if digits are equal in string after operation 1. I mean, this is the first part of the problem, okay? The second part is the third problem. Well, you're given a string S consisting of digits performing the following operation repeatedly until the string has exactly 2 digits. So what is the operation? Okay, I'll just explain you what is the operation. See, let's move on to Excalibur. The operation is basically nothing, but let's say if you're considering it to be a proper string, okay, because you know that string is a character array only, okay. So what you can do is these are consisting of numbers, okay, 1 2 3 4 5 6 7 10, not 10, like this is a consisting of only one digit number, right? Every character is a one digit number. So what you have to do is in the first step you have to add the present digit with the next digit and make it modulo 10. I mean take the last digit, okay. So this 7 becomes 7 plus 8 mod 10. 6 becomes 6 plus 7 mod 10, okay. And you have to continue doing it until unless there are only two elements left, because you can see one thing that on the first step I ignored the 8. So on the next step I will be ignoring the 7, then 6, then 5, then 4, then 3, then 3, okay. And the part I am just left with only two elements. I have to check if the two elements are equal or not, okay. So let's take an example that has been given to us. Let's go with 3902, okay. Let's go with 3902. 3902. So this 0 becomes 0 plus 2. that is 2. This 9 becomes 9 plus 0, right? That is 9. And this 3 becomes 3 plus 9, that is 12. But since we are just going to consider the last digit, so we can write it as 2. Okay. In the next step, what happens? This 9 becomes 9 plus 2, 11, that is 1, the last digit. And this 2 becomes 9 plus 2, 11, and the last digit is 1. So now we are left with only 2 elements, and both of the elements are equal. So we can directly say that it's a yes. Okay, I mean it's a true. Okay. If you want the code, I'll just quickly go through the code. I'm taking the length, and what I'm doing is I'm performing the operation till I find that n greater than 2, because the time complexity is not our main concern. So what we can do is we have to consider moving from the first element to the second last element and add s of I and s of I plus 1, right? And make it mod 10, and then s of I becomes a plus 0. Okay. This is what we are doing, and I can do it in one go because I am moving from left to right. Instead of right to left, I am moving from left to right. So what happens? Left to right, when I am moving, I can make this 3 as 2. I can overwrite it as 2 because I won't be needing that 3 anymore in the calculation further, because I will be needing in the next calculation 9 and 0. Okay. So once I've rewritten this 9, I can cancel it, and I can cancel it because I will be not needing that 9 anymore. I will be needing the 0 and 2 in the next step. Okay. So we can just rewrite it and go on. Any doubt regarding this? Is it clear? Can we move on to the next problem? See, a no answer means yes. Okay. I mean, no, it obviously doesn't mean so. But yeah, just be a little bit responsive in the comments. Okay. Great. Let's move on to the next problem. Maximum sum with at most k elements. Okay. You're given a 2D integer matrix grid of size n into m, an integer array limits of length n, and an integer k. Okay. Your task is to find the maximum sum of at most k elements from the matrix grid such that the number of elements taken from ith row of grid does not exceed limits of I. Okay. What does it mean? It means you're having a grid. Okay. How many questions did you guys do, by the way? Okay, you're having this grid, and for every specific row, I'm having a limit. Okay, I'm having a limit for every specific row. Let's say for this specific row, the limit was 2. For this one, it was 3. For this one, it is 1. This is 2. This is 5. Now, what is this 5, 2, 3? It means that I can take at most that limit number of elements. And in total, I have to take k elements, right? I mean, yeah, it can be lesser than that also. I don't remember. It was, yeah, we have to take at most k element. So at least you have to take, like, you don't know how many elements you have to take, right? But you can take at most k elements in total. But in specific rows, there is a limit set that you can't take elements more than this number. Okay, you can't take more than 2 elements in the first row. In the first row, you can't take more than 2 elements. In the second row, you can't take more than 3 elements. In the third row, you can't take more than 1 element, right? So what is the approach to do it? The approach is very simple. Since you know that in every row you can take some limit number of elements, so you can just do one thing. You can take those maximum element. What do I mean by that? Let's say in the last case, in the last row, what I told that you have to take, you can take at most 5 elements. So just do one thing. From this row, take the maximum 5 elements. Okay. Now you may come up with a question that we can take that maximum 5 elements, but that doesn't mean that all those 5 elements will be counted, right? It may be like none of the 5 elements will be counted. You never know. But for our sake, we can first of all, instead of like we can divide the problem into two parts. I did second question. For third, I was thinking the binomial coefficients for value length of I thought my approach was big O but didn't understand till now why my answer is giving TLE. Your answer is giving TLE, my answer is giving the wrong answer. We'll do it. Okay. Like I eliminated the TLE, but yeah, I'll explain you what I mean. Okay. Now see. So for this case, like if I take out, so what I can do is I can divide this problem into two parts. Okay. Why two parts? Because we know that the number of, like what we have to do is, first of all, there's a limit that is set, and second of all, we have to take at most k elements. So why not first we set the limit and then take the k elements. So using that, what we can do is for every row, okay, for every row. So how many rows are there? 1, 2, 3, 4, 5. 5 rows. From every row, take the limit maximum elements. That is, for the first row, take the 2 maximum elements. For the second row, take the 3 maximum elements. So in total, how many elements are you now with? 5, 6, 7, 8, 9, 10, 11, 12, 13. Total 13, right? And let's say the value of k was 7. Okay. So from this 13, again, you have to take the 7 maximum elements. Right? Is it clear? Like if you want the thing, I can show you the code. So I'm going for grid of this. I'm sorting all the elements and I'm taking the last limit elements. Okay, I'm taking the last limit elements and pushing it into the selected. There's like a vector called selected, and then I'm sorting the selected out and I'm taking the last k elements from here. Okay, that is dividing the problem into two parts. First of all, we have to take from every row the last limit elements, and from the vector that we get after appending all those elements, we have to take the last k elements. Okay, is it clear? Is everything clear? Yes or no? Amit? Okay, Amit to knows it. Amit has done it. Anyone else? Any doubt? Okay. See, check if digits are equal in string after operation 2. Now, if you are watching the pre-recorded version of this, I mean, if you're not watching the live version, so what I'll just prefer you is to go to the first question that I explained and get the question from there. Okay, I'll just explain what is the difference between this and that question. The difference is nothing but you're given the constant of s dot length as 10 to the power 5, but in the first case, you are given the constant to be 100 maximum. So from here you can draw one thing very clearly, that if you're having 10 to the power 5, so you have to find a very efficient way to get it. You can't like loop it out, okay, every time. So let's draw some basic conclusions from here. Okay, let's say, okay, this is very important, this mathematical part. Just a minute. So let's say if you're having various numbers, okay, various numbers in this thing, 1, 2, 3, 4, 5, 6, 7, 8. Okay, but for our convenience, what we are going to do is we are going to take 7 of them. Okay, works. Let's take 7 of them. A, B, C, D, E, F. 1, 2, 3, 4, 5, 6. Let's work with 6. Okay, first of all. So what happens? This becomes E plus F. This becomes D plus E. This becomes C plus D. This becomes B plus C. And this becomes A plus B on the first step, right? Great. On the second step, what happens? this becomes D plus 2E plus F, right? This E and E. This becomes C plus 2D plus E. This becomes B plus 2C plus F, not F, D. And this becomes A plus 2B plus C. Cool. Walk still now. What happens in the next step? This becomes C plus 3D plus 3E plus F. This becomes B plus 3C plus 3D plus E. Okay. If it is not visible to you, this is what I'm doing. And this becomes A plus 3B plus 3C plus D. Okay. Clear? Now what happens after this? After this, this becomes B plus, no, sorry, B plus 4C plus 6D plus 4E plus F. So you can notice one thing, that whatever the pattern is in one element, the same pattern is repeated in the next element. Do you teach R Studio? What is R Studio? I don't know. Okay, it is for R language. No, not into that. Like the maximum AI/ML that I do in my life is with generative AI. Okay, nothing else. Okay, so you can see like there's a pattern, right? So what was the pattern initially? Initially the pattern was 1. Everything was 1, right? So I just use a better marker. So initially the elements were 1. Okay. So from that 1, we get 1 to 1. What do I mean by 1 to 1? Sorry, from that 1 we got 1 1. Sorry, 1 1. What do I mean by 1 1? See, initially it was A, then it become A plus B. So what is 1A plus 1B? After that it become 1A plus 2B plus 1C. So after that it became 1 2 1. After this it became 1 3 3 1. Okay, 1 3 3 1. And after that it became 1 4 6 4 1. 1 4 6 4 1. Now I don't know how many of you have come across this concept called Pascal's triangle. Okay, this is what exactly the Pascal's triangle looks like. Okay. Okay. Well, now since you know that what the Pascal triangles looks like, now you may come up with a formula like you may be asking me that how to calculate it, right? Well, if you notice one more thing very carefully, this part, it is basically nothing, but it can be written as a plus b to the power 1 because it is a plus b. This part, it can be written as a plus b squared, because you know what is the value of a plus b whole squared? It is a squared plus 2ab plus b squared. So what are the coefficients? 1 to 1. Well, now if you are going for a plus b to the power cube, a plus b cubed, you know what is the value going to be? The value is going to be a cubed plus 3a squared b plus 3ab squared plus b cubed, right? Like I don't know how many of you know about this formula, but that is how it works. So basically for every to the power 1, to the power 2, to the power 3, to the power 4, the Pascal's triangle tells us what are the coefficients. Okay. From the Pascal's triangle, we can draw the coefficients. Right? But this is not proper, right? This is also not getting it. Like we can take out the coefficients, but this is something very much theoretical. even logical, even we can prove it down, but to be writing it down in a computer language, it will be difficult for us, right? Even to, like, let's say if it is a plus b to the power n, okay, a plus b to the power n. Now, how can we find it out? Are we going to multiply a plus b, a plus b, a plus b? Nope, we can't do that, right? So it is not possible, right, to do that. So what we can do is, like, there is a formula that this values, it can be written as NCR. Okay. Now what is this NCR value? So let's say for the first case, it is 1, right? Because it is NC0. Then this 4 is NC1. This 6 is NC2. And can you guess what is the value of N over here? Can anyone guess what is the value of N over here? The value of N is nothing but 4. But what is 4? Now this is the most interesting question. What is 4? This length, this ABCD, exactly. This ABCDEF, this length was 6. But we take 4. Which means that whatever the length is, we are going to take N minus 2. And if you go to the constant of this problem, you can see that the minimum length is 3. Why is it 3? Because if it is 2, N minus 2 will become 0. So we have at least one operation to do, right? So now that you have, पीछे से 2x पे देख के देख लो. So now you know one thing, that since you have got this value completely out there, so you can compute the values, okay? And at the end, you are left with b plus 4c plus 6d plus 4e plus f, and the previous element will be a plus 4b. So the same thing, just from a to the second last element, and the second element will be from the second element to the last element, okay? So using that, what we can do is we can compute the sum, okay? And after you have computed the sum, what you can do is you can find out whether the last digit is same or not. Is it clear? Is it clear? हाँ या ना? बोलो बोलो. I was doing the same thing, but in Python. No. You were doing the same thing. You can't be doing the same thing, man. Okay, I think you were what you were doing is you were finding the NCR value, right? One by one. Now, if you are going to find the NCR value one by one, you will get the TAD. But what I did is I used a DP. Okay, I was using a DP. Yeah, I get it. As in first compute coefficient using. But I am using a DP. I don't know whether you used a DP or not. Okay. If you're using a DP, I think you may come up with a approach that it should work, right? But since I was getting a wrong answer, so I'll just check it. You know what? The fact is that I was getting a wrong answer for a very large value. Okay. Because that is where it was getting overflowed. So that's why I have to check. I can show you. N minus 2 plus k. See, it was going for 611. Oh no, I think not this one. This is, I was just playing with it. Yeah, 614, I guess. Yeah, this is the maximum I got. No, it's okay. I get it. Not entered properly. Yeah, get it. So now, since we know, sorry, not this one again. I don't know what the heck is wrong with this. Why can't I see the discuss? Do. Classic mode, okay. They remove the discuss from the dynamic mode. Okay, I think now the discuss will be up. Yeah, the discuss is there. So remember one thing, whenever you can't solve a problem, like obviously we are human beings, right? We come across situation Yeah, I will explain the DP part. See, the DP part is, I'll tell you. No, no, I have to like, the DP part is also not right. Okay, because the DP what I was doing is, since I know that, let's say the previous element is NCR, right? And the, I mean the present element is NCR, and the previous element was NCR minus 1. So do you know this formula? This over here we can place something and multiply it with NCR minus 1. Do you know this formula? There's a formula over there. So that is it. That is it. Since this is the previous element and this is the next current element, so I have to just multiply it with the previous element. That is what the DP approach is. Okay. Okay. So there was some issue with my FPS, I guess, right? For a few seconds. I must be lagging. Okay, I am again lagging. I don't know. This is something. Some problem is there with my RAM, I guess. Okay, simple greedy approach. Flatten the grid into a single list. Convert the 2D into a list of pairs. Flatten list. Select greedily. Count used. Okay, I think I chose the wrong question. Okay, I chose the wrong question. I don't know. I think I did the same thing, but TLE आ गया 673. Okay, 673 case. Well, well, well. You did the same thing, like multiplying. So basically, that would take you big O n only, right? If you're doing the same thing, big O n is what it will take you. But sometimes, like Python doesn't work that way. What were you using to make it modulo, by the way, Amit? This guy has used binomial coefficients only, so we'll just go through his solution. Reducing strings by digit. Okay, I know what. Binomial coefficient modulo 10, yeah. Efficient computation using Lucas algorithm. These are the things that I like fuck up. Now they're coming with some Lucas algorithm, Lucas theorem. To calculate binomial coefficient modulo 10, we split the problem into calculation modulo 2 and 5. Okay. Lucas theorem is used to efficiently compute modulo this bin mod 5 bin mod 2. Combine the result using the Chinese remainder theorem to get the. Now see one thing. Okay, so he has check digits if equal, right? This is it. Oh no, this is the accepted one. This is it, right? So I was getting a TLE for this. Now what this guy has come up with is nothing but, he tells that there is some algorithm called Lucas theorem and some Chinese remainder algorithm by which you can get the modulo 10 thing. Otherwise everything is same, I guess, whatever he has done. Okay, so let's go through his code only, because like I think the explanation was clear enough. So let's see what he has done. So int bin mod 10. So this is a Chinese remainder algorithm. Let's go through it. I don't know what is a Chinese remainder algorithm. Okay, we are given two arrays and remember reminder in nums for every pair is co-prime. GCD for every pair we find basically we are given k numbers which are pairwise co-prime, given remainder of these numbers when okay, I get it. So see what he has done is, since you know that whenever you're having, if you're doing that this thing ncr mod p, the maximum algorithm that I could come up with is not the Lucas one, but I think I know about the little format algorithm if I'm not wrong with the term. So what in the little format thing happens is like you just go on doing it with mod inverse. Okay, I think he has used mod inverse somewhere. I think Lucas doesn't use the mod inverse thing. So yeah, I get it. Okay, so what happens is you get the mod inverse. Now say for this NCR mod P, what you're going to do is you can find out the value of it, but that only happens if this P is a prime number. Okay, this only happens if this P is a prime number. Now since we know that obviously we are going to check for the last digit, right? That is 10, and 10 is not a prime number, right? But what we can do is we can divide this 10 into two parts, that is 2 into 5, such that is 2 is also a prime number and 5 is also a prime number. Like I think his explanation, he didn't explain why he is doing this 2 and 5. Yeah, he has explained it. It is prime powers, okay. Because yeah, we can only do it with prime numbers or prime power numbers, okay. So you can use the Lucas theorem. You will get it on, I think you will get it online. You can use the Lucas theorem, and after that what you can do is you can check out this thing called Chinese remainder theorem. Even I don't know what the heck it is. So what it does is it's just to like get the modulo 5, modulo 2, and then get the modulo 10 from those two values. Okay, it is bin mod 2, bin mod 5 is getting it, and then he is running. This is the Chinese theorem. Okay, this is the Chinese theorem basically. I think we can make it out from here. What he means is, let's say if I mod 2 is equal to mod, and this is okay. I get it. So what he does is, I'll tell you what he has done over here. Now, since you know that the value of 2 and 5 are both, it like 2 can have two values, right? The modulo, after modulo, it can have either 0 or 1. And this 5 can have from 0 to 4, right? So for every specific pairs, okay, so for every specific pairs, so I'll explain you what he has done. See, for every specific pair, so let's say if he is having, let me just write it down. Okay, so from this 0 to 4, what I can write it as 0, 1, 2, 3, 4, right? Then I can also write 0, 1, 2, 3, 4, okay? And for every of them, this is going to be 0, 0, 0, 0, and this is going to be 1, 1, 1, 1, 1. Now, let's say if I want to find out what is the total modulo of that, okay, which means that total modulo of this is 0, this is 1, this is 2, this is 3, this is 4, this is again 1, this is 2, this is 3. So like we can go on doing it, okay. What he has done is he is going to find out the modulo of 10 for which the modulo of 2 is equal to the modulo of 2 that we got, and modulo of 5 is equal to the modulo of 5 that we got. So he is checking out for all the modulo of 10s. Okay, for 10, how many modulos are there? From 0 to 9. I mean the modulo answer. Okay, so for every specific element, he is going to check what is that element mod 2 is, what is that element mod 5 is, and if it matches with the mod 2 of the number that we have got and mod 5 of the number that we have got, he tells that this is the answer. Is it clear? Like this is a very interesting algorithm, like Chinese remainder algorithm, whatever it is. Like yeah, so this is what he has done basically. If you want the proof of it, I can show you quickly. So let's say if mod 10 is 0, okay, mod 10 is 0, now that means that mod 2 will be also 0 and mod 5 will also be 0, right? If mod 10 is 1, okay, so I will write it 1 0 1 2 3 4 5. So let's do for the first 5 first. So if mod this is 1, so this and this will be 1. Okay. If it is 2, so this will be mod 2 will be 0, but this mod 5 will be 2. For 3, mod 2 will be, this is mod 2, okay, and this is mod 5. So for 3, mod 2 will be 1 and mod 5 will be 3. For 4, mod 2 will be 0 and this will be 4. For 5, it will be 1 and 0 because 5 mod 5 is 0, okay. For 6, it will be 0 and 1. For 7, it will be uh, 1 and 2. For 8, it will be 0 and 3. For 9, it will be 1 and 4. And for 10, you don't need it, okay. For 10, again, you come back to that specific value. So you can notice one thing, that all the pairs that I have got from here, all of them are unique, right? All of them are unique. Because how many possible ways are there? So this is basically 0 and 1, which means there are two possible ways, and for 5 it is 0 to 4, which means there are 5 possible ways. So if you go for permutation combination, so it is going to be, in this part we can have 2 possible ways, and in this part we can have 5 possible ways. That is 2 into 5, that is 10 ways we can have. And for 10, the modulos are going to be from 0 to 9, that is, there are 10 possible ways. Okay. So is it clear what he has done? This Lucas thing, you can check it out on the GFG. Like, this is very simple. Like, they do some calculations. Bin mod 2, bin mod 5, bin small. That is for, I think this is one is for very small numbers. So in case of very small numbers, you can use brute force, somewhat like that. Bin mod 2 is very easy. Like, you can find out if that element is, like, if the answer is odd, then it's a 1. If it is even, it's a 0. Okay, this is very easy. And bin mod 5 is also very easy, because bin mod 5 is basically going to give you either the last element or the last element plus 5. I mean, sorry, last element minus 5. Okay, so this is what it is all about. Is it clear, everyone? Is it clear? Haan ya na? And I'm audible, right? That's clear, haan ya na? Yeah, I'm audible. Will DP approach that you have will be the time complexity and wanted work? What he has done over here is basically taking, he has also done a little bit of DP only, but he is over here, I think he's more about concerned about this denominator thing, I mean this thing, bin mod thing. Okay, so bin mod m comma I, so he's just taking the n comma k, so he is not even doing the DP also. What he is doing is, okay, he's not even taking the DP, because you can do it even better approach. And why the DP approach will not work, if you want to know, will that you have, what will be the time constant and won't it work? No, it won't work. I'll tell you why. See, what we were doing in the DP was, we were not using the prime factor, right? We're not using the prime factor. And if you're using the prime factor, so the DP approach, even in that case, won't work. Because what happens is, see, in the DP, whatever you are doing, sorry. So what I just told you in the DP was, you're doing NCR is equal to some number into NCR minus 1. but this sum number is n plus k minus 1 by k, if I'm not wrong. I don't remember. Okay. Somewhat like this. Okay. N plus k minus 1 by k. Now this number, it is not possible that always it will be an integer. It may be a double number also. I mean a float number also. A decimal number also, right? So in that case, when this will be a decimal number, it won't work. Because what happens? N minus k plus 1. Oh, okay, okay, yeah, right, sorry. N plus k minus. This though obviously is wrong. N minus k plus 1, right? So this will be a wrong thing, right, to do. And one more thing that is happening is, so let's say ncr minus 1 is nothing but it, let's say it is 10. Okay, we can, like, if you go through the whole Pascal triangle, you will find that for one case there is a pattern of 1 5 10 5 1. Okay, so in that case this will be 10, right? Now once it is a 10, now since we are going for the modulo of 10, so this becomes 0, right? This becomes 0, the modulo of 10. And since this becomes 0, so any number into 0 is basically 0 only. So once we get a 0 at the digit, so it becomes 0 0 0 0, which shouldn't be the answer. Okay, which shouldn't be the case. So that is the reason why my approach won't work. Okay, is it clear? Should we move on to the next problem? Some extent I will check again. Yeah, like it is not much of a thing. Okay, like if you get this thing, this 2 and 5 using Lucas theorem, or maybe I'll suggest you, like, since I'm not a big fan of Lucas theorem, so I'll suggest you go for little format theorem. Okay, little format, I don't remember what it is. It goes by somewhat that name only, little format. Yeah, little format theorem. So it does. Oh, okay, 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 okay. I think little formats is a different theorem. Oh, okay, sorry. My mistake. Little format is a different thing. You have to go with the Lucas theorem only, okay? And I have, like, I'm not a big fan of just going through all the theorems, okay? It's like whenever I'm, like, if I'm going for some interview or stuff like that, so in that case, what I'll do is I'll just go through all the theorems minutely. But I think since it is available on the internet, so you won't need that, okay? Yeah, Lucas theorem is a result about binomial coefficient modulo of prime, and you can see over here that it is basically based on the Pascal's triangle only. Okay, it is basically based on the Pascal's triangle. Okay, so you can have the odd even thing, what he has done over here. So this odd even is just for the case of 2 bin mod 2, but if you're going for some bin mod 5 or somewhat like that, so you can have a different thing. Okay? If you want, if you're a fan of mathematics, you can read the proof of it. I think you will find it on the internet. Okay, so let's move on to this problem. Maximize. Okay, maximize the distance between points on a square. What is the problem about? I'll explain it quickly. You're given a square. Okay, oops, why didn't everything get deleted? So you're basically given a square. Okay. What are the coordinates of a square? The coordinates are, this starts from 0, 0. So this is going to be 0, side, or yeah, 0, side. This is going to be side, side, and this is going to be side, 0. Right? Now you're given few points which are there on this only, on this lines only, on this, on the sides of the things. Okay, clear? So you're given some points. So you have to take key points among them, and you have to find what is the minimum distance between it, and you have to maximize this minimum distance among the key points. Okay, not clear? I'll explain you what I mean by that. What I mean by that is, let's say if you're taking key points, okay. So let's say the minimum distance among these key points is between this point and this point. So this is the answer for us. Now, if we had the opportunity of taking any other 4 points, okay, such that the minimum distance was something which will be greater than this. Okay, I think I forgot to point it down. Okay, so let's say if you're having 4 points and the minimum distance is between these 2 points, so you know that this is value is, let's say this is some value, okay. But if you're having other 4 points, okay, let's say other 4 points, like I don't mean by point a number. So let's say if you're having some other colored points, okay, orange. Oh, the orange is not that much distinguishable. Let's say you're having this black points, okay, 4 black points. Now the minimum distance between these 4 black points is between this and this point, and that is, let's say, this. Now if this value, it is greater than this blue value, so we are going to take the greater value. Okay, so that is what we have to do. We have to find the maximum of the minimum distance. Approach: binary search, greedy, circular array handling, coordinate transformation. Since all given points lie on the boundary of a square, we can linearize the problem by mapping each point to a 1D coordinate along the square's perimeter. Very good. What do we mean by that? Nothing much. He meant is, I'll just put it over here. What he meant is, if you know that there is a square, okay, and all the points are on the square, what we can do is, we can flatten this whole square. What do I mean by that? Let's say this square, it starts from this point and ends at that point. So what I can do is, this starting, and let's say this is the ending point. So I can put this starting point and the ending point, and I can divide it into 4 parts. Okay, 1, 2, 3, 4. Okay, so this is the square, what it feels like, and at every part you see that there is a element at the middle. Okay, there is a point at the middle, so there is a point over here, point over here, point over here, point over here. So using this, what we can do is, we can get every point in a linear pattern, that is in a 1D pattern. Okay, but that doesn't satisfy the factor that how can we find the Manhattan distance, because what we have to do is, we have to find out the smallest Manhattan distance between them. And what is the Manhattan distance? It is basically x2 minus x1 plus y2 minus y1. Now since we know that we are finding the Manhattan distance, so let's say if I'm having a point over here and over here, the Manhattan distance is this, right? Now if you notice one thing, since all the points are on the same square, so the Manhattan distance can also be this. Okay, so what is the Manhattan distance? This. So how can we calculate this? This is basically nothing but this plus this, right? If you look into the 2D thing. So basically we are just not only making it in the 2D, we are also making a circular pattern over here, so that it works. Okay, and after that we have to find out, like, we have to do a binary search. Okay, this is somewhat similar to the fact that there is a sorted array You don't know whether where like from where it starts, because the array is circularly sorted. So you have to find the starting point, somewhat like that. Okay. So you have done the mapping to 1D. What he is doing is the bottom edge y is equal to 0. He's making it tx. Then he's making the other part side plus y. Then 3 into side minus x, and 4 into side minus y. Okay. This is basically mapping it to 1D. Whatever I explained over here. Okay. Like you can find out the formula. Now since like he is not starting from here, he is starting from here. Okay. Now since he is starting from here, so this line everything is same. Okay. This line is same. So I'll just try to visualize this. Okay. I'm having a square. Okay. What I'm doing is I'm going to flatten it up. So when I'm drawing a black, remember that it means that I'm going to erase it. Okay. So what I can do is I can bend this part and make it flat. Okay. So what happens if I bend this part and make it flat? This becomes like this. Okay. Right? This becomes like this. Sorry. Not like this, but like this. Right? Because I have bent this. So let's say it was like this. I have bent it like this. Now again what I can do is I can bend this part. Okay. This part. So what happens now? It becomes like this. Then what I can do is I can bend this part. So it becomes another straight line. Okay. Clear? Now what you can do is for every point you can find out what is the point in the 1D thing. So this is very simple. So over here he has come up with some formulas to do it, but you can just mentally do it out yourself. Okay, if y is equal to 0, t is equal to x. This is the last question. Okay, Shikha. So for the first case, you know that it is what it is. Okay, so you don't have to think about it if t is equal to x. But for the remaining cases, what he is doing is, so if y is equal to 0, so t is equal to direct x. But let's say if x equal to side, what does it mean? That is this part. Okay, this thing. So what will be the value of this? It is basically nothing but whatever is in the y index, right? That is the value. So if you look at it, it is basically side plus whatever is there in the y index. Why does it do side plus y index? Because we have already covered this side part. Okay, this part has already been covered. So more y index is there. So using that, he comes up with this formula. For y is equal to side, that is for this line. Okay, for this line what happens? It is going to be, since you know that this was like this, okay, and then we moved it completely at 180 degrees angle. So we can't find out what is the value of that part. So we have to negatively minus it. Okay, so he's negatively minusing it. That is 3 into side minus x, and then it is 4 into side minus y. Okay, if x is equal to 0, what is x equal to 0? X is equal to 0 is this part. Okay, because you know one thing, I'll just show you one thing, what why he is doing 4 into side minus x. So let's say there is a point over here. Okay, and okay, yeah, there's a point over here. Okay, and instead of taking this point in this line, I'm going to take this point in this line. So what happens where this point goes? This point goes at the end, at the very end, right? Instead of coming at the beginning, it comes at the very end. So that is the reason we are going to do 4 into side minus x. Clear? Is it clear or not? Okay, so is mapping to 1D clear? Tell me. Now I'm doing a poll. Oh, is mapping to 1D clear? Can you tell in long? Okay, just a minute. How to remove this? Yeah. Can you tell in long term how Lucas theorem or other theorem or remembering fourth question approach help in long term? As in, I might not even remember these approaches after a long time. Sharpens brain, I guess. See, the thing is that if you're coming across like let's consider this DP thing, okay, dynamic programming. So when I was just a beginner out there, so what I used to do is like I couldn't come up with solutions for a DP, okay, and at that point of time I used to think that I have to memorize a lot of things, like how this memorization works, how this tabulation works, and like how to come up with it. Then that 0 1 knapsack, I used to memorize the 0 1 knapsack problem, okay, but as time went out, so I used to understand them, and at this phase like I can code it down without even seeing it. But if you're talking about DFS and BFS, okay, now I know the approach, I know the theory how it works, but I don't, like I can't code it down that fast, okay, as fast I can do with the DP things. So in that case, what I'll do is I'll just go to the GHG portal and just copy paste it, okay. Now what is the difference between this BFS DFS and little format? That is, sorry, Lucas theorem, not little format. Lucas theorem is that I don't even know how this Lucas theorem works, but since I know that Lucas theorem is something in which you can have the NCR mod P, okay, so what we can do is directly, and this P has to be prime always. So what I can do is I can just remember that in my brain, because if I am doing a lot of problems on Lucas theorem, let's say in the next Leetcode contest also they come up with the third question which uses Lucas theorem, okay, and even the fourth question that uses Lucas theorem. So what happens is in every week you are doing something related to the Lucas theorem, right? So in that case, you get habituated to it. So it's like more of like that, okay, and it's normal. Like we are human beings at all. We don't have to remember everything. It is not possible for us, right? Okay, so let's move on to this sorting an extended array. Okay, sort the mapped coordinates to handle the circular nature of the perimeter of total length L is equal to 4 into side. Create an extended array by duplicating the sorted array and adding L to each element in duplicate. This allows us to treat this circle as a straight line when checking gaps. Okay, so what does he mean? To handle the circular nature, create an extended array. Okay, sort the mapped coordinates. So what you can do is you can sort the map coordinates, obviously. The sorting is basically nothing but like, since till now what we were doing is we were just finding the points, right? We're just finding the points, but these points were not in a proper order. So it may happen that at the beginning we found out this point, and then we found out this point, right? So obviously that, so we have to sort it out, okay. So what, that is the first thing, so we can sort it out. That is, see, one thing, that whatever I was explaining I was just visualizing. I'm not going through the code right now, I'm just visualizing the whole thing. So I am just going as much close as to my visualization through the code. So for then I sort it out. So now what happens, everything is as it is, as it is in the visualization, okay, everything one after the other. Now since there is a circular pattern, which means that there will be a position, that this part comes after this, right? There is a position such like that. We can't do that, right? But what we can do is we can repeat this line, okay. So let's say there was a line like this, okay, okay. Now which means that this point will be connected to, let's say there is a line over here, so this point will be connected to this, right? So instead of connecting that back to that, because that will form a cycle over there, so what we can do is we can repeat the whole thing, okay, and we can connect it like this. Okay, so this is nothing, okay, this is nothing, ignore this line. Okay, so what we are doing, we are just connecting, we are just sorting it first, then duplicating it, sorting it, then duplicating it, okay, making two parts, and then we are just connecting the duplicates. Clear? Is it clear? So what to do? Sorting an extended array. Is it clear? Let me start a poll. Is this part clear? I need some votes so that I can move on to binary search on candidate distance. No. Why no? Like write it in the live chat. Can you quickly summarize till now? Summarize till now. Okay. Sure. Couldn't follow. Okay, okay, okay. No problem. See, first of all, since it was a square like this, so consider this as a wire. Okay, this square is a wire. So what we are doing is, first of all, we are bending the wires. So let's say if there is a 90-degree angle between two squares, so we are bending it. So first of all, we bend this part. So now it becomes like this, right? Then we bend this part. So it becomes like this. Okay. Then we bend this part. So it becomes like this. Okay. Now we have a 1D line. Okay. We have a 1D line. So we can have the points on it. So there you can find out some specific formulas to find out. So in that 1D line, we have that point. Okay. After that, what we do is, since we know that this point over here, this is connected to this point, right? That is, there is a circular connection. But our main motive will be breaking out if we are doing the circular connection. That is to make it in a 1D line, right? So what we are going to do is, we are going to repeat the whole thing. Okay, we are going to duplicate the whole thing and then connect this end to this front so that it will be simulating a similar type of response. Okay, it is not circular, it is one directional, but the answer that we are going to get, it will feel like it is circular. Okay, this is till now what has happened. Is it clear? And whoever said no, I think I'm just guessing it is Amit only. So I think now it is clear for you, right? What is the meaning of this connection thing? This connection thing. This connection thing is basically, okay, I'll just explain you. Okay, I'll just tell you what I mean. Let's say there are various nodes. Okay, 1, 4. Sorry. Okay, so let's say there are various nodes 1, 4, and 5, right? There are various nodes. Now our aim is, like, the end point, we have to connect to the first point. Why? Because the square is like a wire like this. Okay, where the end and the starting is connected, right? The end and the starting is connected. But in this case, we are not connecting it, right? We are doing it in the 1D manner. So we have to connect this two, right? Now, the moment we connect it, the main motive, that is to keep it one directional, it breaks. So instead of doing that, what we are going to do is, we are going to duplicate the whole thing. We are going to make it 1, 4, 5 again. Okay. And after that, the last point I am going to connect to the first point of this. So it is still a 1D. Okay, got it. Great. Now let's go with the next part. Binary search on the candidate distance. Use binary search to determine the maximum candidate minimum distance in the range 0, 2 into text of site. Okay. What do we mean by that, by the way? Binary search to determine the maximum candidate minimum distance. Okay, let's walk on through his code. can place given sorted 1D and candidate distance. Oh, yes, calculate the candidate distance. Check if we can select k points around the circle. Perimeter L is equal to 4 into side. Maximum distance can be 0 to 2 into side. Yeah, I get it. That I get. But what is this text? I'm not getting this. I think we will find the okay, first let me end this poll. Otherwise it is error. Oh, okay. Yeah, that is latex. Right. Sorry. Yeah, that is latex. So yeah, so we can binary search on the candidate distance. Okay, because we know that the yeah, so we can binary search on the candidate because we know that the distance can never exceed 2 into side. Okay, the distance can never exceed 2 into side. That is, the distance can never exceed this. So we can find out the binary search on all the distances. Now what we can do is, once we have found out the binary search, then for every specific distance of D, we perform a greedy selection of the extended array. Start from each possible starting index in the original sorted array. Greedily select the next point that is at least D away from the last chosen point. Ensure that after selecting k points, the wrap around gap from the last chosen back to the first adjusted by L is also at least D. So what he is doing, since we know, okay, I again have to, like, Excalibur is doing a lot of problem these days. Like, I get it because there are so many people using it. Yeah, it's okay. So what he is basically doing, let's say we are having the whole thing now, okay, various points on it. So we can have a binary search on 0 to 2 into side, okay, because that is the maximum. 2 into side is the maximum distance that we can have. Why so? Because let's say if in the square there are 2 points, okay, so what is the maximum distance? This and this, okay. For any point it can't exceed this much or this much, okay, because if it is exceeding this, so let's say you may come up with a solution that what if this is at this point and this is at this point and this is exceeding it. So we are not going to take that, right? We are going to take this distance. Okay, sorry, let's say there are 2 points, so we are not going to take the red distance, right? We are going to take the green distance. So it may seem that it may exceed it, but it will never exceed it. So we can find a binary search, and on that binary search, let's say if you're getting a value of D, so you can find out all the elements, okay, that we can consider starting from every specific point, because we know one thing, that the points, how many points are there? It is 15 into 10 cubed. So we can have big O n squared approach. So for every starting point, let's say I'm starting from this point and then I find out what is the next point after D distance. So let's say after D distance it comes at this position. So what is the next point? This. From here D distance it is at this position. Next point this. D distance this position. Next point this. So using that, what we can do is we can find out all the elements. Okay. Then we can start from here and then find the D distance, next element, D distance, next element, D distance, next element. Okay. So for every specific starting point, we can find for D distance what is the number of elements that we can have. Okay. What is the number of elements that we can have? Now, if the number of elements that we can have is greater than K, so what we can do is we can now try to increase the distance more. So that is the reason we were using binary search, because if it is exceeding, if it is lesser than K, so let's say if I'm taking a distance of value D and putting that into consideration, the number of points that I can have is maximum is 3, but I need at least 4 points. So I can't go with D, I have to increase the value of D. Okay, and how to increase the value of D in binary search? D is not, it is L is equal to mid plus 1, right? That is the formula, you know. So that is the reason we are using the binary search. Okay, and then putting the feasibility check with greedy, and then we return the answer. Till now, any doubt? Like this is the whole solution only. But any doubt, anyone? Now that I think I could have come up with at least the binary thing, but not linearizing the square. Also, I spent a lot of time on C. Even I did it. Don't need to worry. It happens. Okay. So is it clear? Is D clear? Is everything clear? Today's contest clear? I think it is clear. It's like yeah, I have gone through it. So it's time to read the problems. Easy, medium, hard, very hard, very easy. Okay. The last line is nothing. Okay. The last line is nothing. The question have become relatively difficult. I think today's contest was still easier than the previous contest. Just the thing is that uh, you couldn't have come up with the approach. Okay, that easy. See, the first problem was very much easy. Okay, it is going to be in this easy part only. The second problem was what was it? I don't remember. Check if digits are equal in operation. The second problem was maximum sum. Clear, Hayana? Well, I think now I am connected properly, right? Now the connection is so stable. Well, I think now I am connected. Okay, great, great, great. So there was some disconnection from my side. Okay. So what I was doing is I don't know whether you have heard me or not. Amit, I was telling you that it is not that it was difficult than all the earlier problems, but the previous one, just the previous one, I think that was more difficult. Okay, the previous contest, the previous Sunday one, that was difficult. And lead questions, yeah, it has become relatively difficult. This is something that I will agree with. Okay, so this is the rating. A was very easy, B was medium. Yeah, nowadays in general it is becoming difficult, right? Like like earlier what you used to have I used to do is like I'll just explain you that. So let's say like B was medium and C was hard because like you have to come up with that two five prime numbers and then mix it up. So that was a little bit of brainstorming, and D was a lot of brainstorming. Okay, to be honest, a lot of brainstorming. The binary search, apart from that, it may seem very easy, but to come up with that in such a less amount of time, it was like even if we don't give it a very hard tag, we can give it a hard tag. And what we can do is we can make this C somewhere over here. Okay, between medium and hard. So that is the best thing. I think to evaluate LLMs, they are making a better training set for maybe. You never know. Deep sick is in the market now, right? Okay, so yeah, nowadays in general, because like earlier, what used to happen is I used to like there was a habit that I used to solve almost all the problems or at least three problems. Okay, but now at this moment it may be because like I have lost that practice, that practice thing is not there anymore. But apart from that also, like it seems that the problems are getting hard. So at the third problem I start struggling. Okay, and earlier, like if I'm struggling, it means that it is the last problem, but now I'm struggling at the third problem only itself. So yeah, that's it. Like that's it. Okay, so any more doubts? I think today's contest, like every solution was very much clear with you guys. So let's end the stream. Okay. Okay, got it. Thanks. Great. Bye, guys. Radhe Radhe.